So welcome to the first class of LeetCode coding. Let's start today's class. Let's look at some questions. If you have any doubts, do let me know. I'll try my best to clear those up. Okay, so the first question that we are going to see today is called twosome. Let us try to understand the question first, and then we'll see different approaches. We'll start with the brute force approach and we'll make our way to the optimal approach, so that we can understand how can we build upon a particular question and reach from a very basic approach to an approach that is able to solve all the test cases. So what is the question? So given an array of integers nums and an integer target, return indices of two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So let's have a look at the examples. So the first example is, look at the nums array, 2, 7, 11 and 15. The target is 9. Let's copy this example onto our whiteboard and try to understand what the answer should be. Let's increase the font size so it's clearly visible. So this is the first test case that is visible. Let's try to understand what the answer should be. So what do we want to find out? We need to find out two numbers whose sum is exactly 9. Alright. So every array would contain the answer that is given in the question. So let's try to understand how we can find that. So the first approach that will come to your mind should be a brute force approach. We can sum up each pair of elements and find if its sum is equal to 9 or not. So let's try to find out the sum of the first two elements. So 2 and 7, it's 9. Right? So we have found the elements that we wanted to. We'll create another array and fill up their indices. So 2 is on index 0, 7 is on index 1, and this becomes our answer. So in case you don't find them right off the bat, what we'll have to do is we'll have to sum up each pair of elements. So we'll have to sum 2 with 7, then we'll have to sum 2 with 11, moving on we'll have to sum 2 with 15, then we'll have to sum 7 with all other elements and so on. So how many pair of elements can we create out of an array? So let us see, let us have a look at that. How we code this approach. Okay, so the approach is very simple, it's a brute force approach. We are pairing each pair of elements. We are summing up each pair of elements and we are checking if their sum is equal to 9 or not. That's it. So we are going to use nested loops for this. So for int I equal to 0, I less than, the name of the array is nums, so it's nums.length and I plus plus. Okay, so this is our first loop that is running from 0 to the length of the array. We'll nest another loop for, inside it for int j equal to I plus 1. J less than nums.length j plus plus. Inside these four loops, we'll find the answer. We'll find the sum of the element at ith location and jth location. So now if nums of I plus nums of j, if the sum is equal to target, we'll create a 1D array. We'll create a 1D array of integers int add. We'll put in both the indices into it. Let's say I and j. Right? And we'll return this array as the answer. So return add. We'll close if, we'll close the two for loops. Alright, so here in the brute force approach, what we are doing is we are selecting each pair of elements that we can, summing them up and checking if they are equal to the target or not. Let's try to code this. Okay. So here we'll run the two for loops. I equal to 0. I less than num for length I plus plus. For int j equal to 0, j less than nums dot. We actually have to start j with I plus 1 and j plus plus. And if nums of I plus nums of j is equal to target, we have to create an integer array, we put I and j into it, and we simply return this array that we have created. In case you are not able to find the two elements, although in the question it is written that they will always be there, we'll create another array, A. Let's just put dummy values into it and return it. Alright, let's try to run this. So you can see the visible test cases have passed. Let's try to submit this. So all the test cases have passed. Alright, but we can see that we are only able to beat 24 or 25% of people who have submitted this code. So what we'll do is we'll try to create a more optimized solution that uses lesser time complexity. So for that, we firstly have to understand what is the time complexity of the current brute force solution. So let's see. So there are two for loops, nested one inside the other, and they are independent of each other. So the time complexity is, for the first one it is O of n, for the second one it is O of n as well. We multiply these two together and we get O of n squared. So this is our time complexity. Let us see what a more optimal solution could be. So from the question, it's clear that the arrays that we are talking about, the array that we are talking about nums, it is not sorted. So either we can sort it and then think of a solution, or we can straight away think of a solution that uses even lesser time complexity than sorting. Sorting takes a minimum of O of n log n time complexity. So if you want to solve it in O of n, let's see how we can do that. For that, we'll have to use the concept of hash maps. I hope you are familiar with that. So let's get started. We'll create a hash map. Okay. So let's take the second example and try to solve it with a new approach. This is the second input. We just increase its size. Let's try to solve it with the new approach that we have. We'll use a hash map over here. So let's say this is our hash map. We can't solve it using a hash set. We have to use a hash map. Why? Because we need to insert the indices. Okay, we don't just have to tell if these elements exist or not. We also have to return the indices. So we'll just see how we are making use of that. So what we'll do is we'll iterate through the array. So firstly, we'll land on 3. We'll check if 6 minus 3, okay, the number that should be added to 3 to make it equal to target. So 6 minus 3 is 3 already in the map. No, it's not. Currently the map is empty. So we'll put 3 into it along with its index. Next, we'll move to 2. So 6 minus 2 is 4. Is 4 already in the map? No, it's not. So we'll put 2 here. We'll move forward to 4. 4. So 6 minus 4 is 2. Is 2 already in the map? Yes, it is. So what we have to do is, we have to create an array. We have to put this index into it and the current value of I, where I currently is. We'll put these two values into our 1D array and return that. And that would be our concept. I hope the logic is clear. Now let's move on to coding. If there's any issue at any point of time, feel free to let me know. You can always send your doubts across on chat. So let's clear this approach and apply the new approach. Let's create a hash map. Okay, here. comma, repeat. This one, hash map, new, hash map. So we have created the hash map that we'll be using to solve this problem. Let's now iterate through the now if num_phi, take if num_phi, target minus num_phi is already in the hash map or not. So how do we check it? Dot contains key is the function used to take that. Its value is already in the map or not, right? It will return a true or false. If it returns a true, what do we have to do? We have to create a 1D array. This is array, ARR. What values do we insert into this 1D array? First, where did we find target minus nums? So hm dot get target minus nums. Secondly, the current value of I. Right, we'll put these two values and return the array. On the 1D array that we have just created. Right. If this is not the case, if we did not find the counterpart, what do? We put the current element into our map. hm dot put first index is going to be the value num_phi. Is going to be num_phi and the value is going to be I. After this is over, let's create another array A. Fill it with the values. Return it. That's it. Let's try to run this code. Some test cases have passed. Let's try to submit this. Alright, so all the test cases have passed and now we are able to beat 99.31% of all the users on LeetCode. So let's see what is the time complexity of this code. So we are iterating through the array only once. Right? We are iterating through the entire array once and we are completing our once. So the time complexity gets reduced to O of n. But there is one catch, we have used an extra hash map. So the space complexity also rises to O of n. Right. So whenever you are coding, either it's competitive coding or for any interviews or any placement exam, remember complexity is more important, usually more important than space complexity. So if you can use a little bit of extra space and reduce the time complexity, then that would be a very good thing. So consider that, right? So you can use extra space to save upon your time. Always remember that. All right. So I hope this much is clear to all of you. So now we'll move on to the next question. So if there's any doubt at any point of time, feel free to ping me on chat. Right, I'll be more than happy to clarify all the doubts. Let's see what the second question is. So the name of the second question is best time to buy and sell stocks. Let's understand what the question is. We are given an array prices. The prices of I is the price of a given stock on ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return a 0. Alright, let's see how we can solve this question. So there has to be a day where we buy the stock and there has to be a day where we sell the stock. So to solve this question, we'll use a very simple approach. Just look at it very carefully, what we are going to do. Let's take an example from the question to understand our approach better. So these are the prices on 5 different days, 6 different days. Increase the font size. Okay, so these are the prices of our stock on 6 different days. We need to buy the stock on a particular day and then sell it on another particular day in the future. And we have to make the maximum profit by. So what we'll do here is, we'll start traversing the array, and by traversing the array, we'll find the minimum number that we have seen so far. Okay, and we'll consider that the index that on which we are currently, that is the day we are selling the stock. So if they are selling a stock on any day, let's say ith day, right? And we already have the number, that is the minimum number till that position. So with these two information, what we can do is we can find the maximum profit that we can achieve by selling the stock on ith day. How can we do that? The selling price is going to be the price on ith day, and the cost price, the price at which we buy the stock, is going to be the minimum price till the ith day, because that is going to maximize our profit. All right. So this is the concept that we'll use here. Let's see how we can code that in. So we're going to maintain to store the minimum price we have seen so far. Let's name it min. So starting with terms of prices of 0. We're going to maintain the profit variable. So what is the maximum profit we have got so far? Now we'll iterate the I equal to 1, I less than prices or length, I plus plus. Now if prices of I, basically you just try to update the value of min so far. So min so far is now equal to math dot min so far comma prices of I. We have stored the minimum value that we have seen till now in min so far. Prior to this, what we'll do is we'll calculate the profit. So we want to maximize the profit, so it's math.max profit comma what is the profit that we can get if we sell the stock today on the ith location. So it's in so far minus prices of I. It's prices of I minus min so far minus cost price. Alright. So we have calculated the profit. We just return the profit. Try to run this. Okay. So we have chosen the wrong language. This said use the correct language over here. Just paste our code in and try to run this. Alright, so the visible test cases have passed. Let's try to submit this. So as you can see, the solution has been accepted and all the test cases have passed. Alright, I hope the question is clear, the approach is clear, and the answer is clear as well. And how the approach is also clear. Right, if there's any issue, let me know in the chat and I'll get back to you. So moving on to the next question for the day. So it contains duplicate. So let's try to understand what the question is. Given an integer array now, return true if any value appears at least twice in the array, and return false if every element is distinct. So how can we solve this question? So first of all, let's see a very brute force approach of solving this. So what we'll do is we'll consider every two values. If they are same, we'll return a true, otherwise we'll return a false. So for that, what do we need to do? We need two for loops that are nested inside one another. So let's code that in. So what we'll do is for int I equal to 0, I less than nums dot length and I plus plus. Okay. We'll nest another for into it. Int j equal to I plus 1, j less than nums dot length and j plus plus. Now we'll check if nums of I is indeed equal to nums of j. If they are equal, we'll simply return true. Else we'll return false. So here what we are doing is, we are checking each and every pair of elements. If they are the same, then we are returning true, otherwise we are returning false. The time complexity for the whole code is again of x, like we computed in the last brute force solution. This is the brute force approach. Let's try to code this in, then we'll move on to the more optimized approaches. It's for I equal to 0, I less than. Okay, let's select the correct language first. For I equal to 0, I less than num dot length I plus plus. Okay, for a equal to I plus 1, a less than num length and a plus plus. Now if nums of I is equal to nums of j, return. No such condition arose that we never return true, we'll just return false, which means that no two elements in this particular array are same. They're all unique. Let's try to run this. All the visible test cases have passed. Let's try to submit this. So you can see that we are getting a TLE. 70 out of the 74 test cases have passed, but we are not able to pass the final 4 test cases. For this, we need a more efficient approach. How will we do that? Let's see. So what we'll do is we'll create a hash set now. We'll create a hash set. We'll one by one put all the numbers into this hash set. Let's say this is our array 1, 2, 3, 1. So first of all, we get to 1, we check if it's already in the hash set or not. No, it's not. We'll put 1 there. We'll move to 2. Is 2 already in the hash set? No. We'll put that there. Is 3 already in the hash set? No. We'll put that there. We'll get to 1. It's already in the hash set. If this number is already in the hash set, that means that it has occurred already, which means that there is a duplicacy. We'll simply return true. If this is not the case, we'll just return false. Let's try to code this solution now. So I'll just reset this. Alright. So let's try to code this in now. So we'll create a hash set of integers s equal to new hash set. And that's it. So hash set has been created. Let's try to loop through the array. Now we're looping through the array. If hash set already contains the number that we are looking at, that is nums of I, that means the number already existed in the array. We'll return a true. If this is not the case, we'll return a false. So what we'll do is we'll add the current element to the hash set, right? So hs dot add nums of I. So that's all. Let's try to run this. Okay, let's submit this. So we have successfully passed all the test cases. Let's move on to the next question for the day. This is also the last question for the day. Minimum survey. So we'll use the Cadence algorithm to solve this particular problem. Without the Cadence algorithm, it is not possible to solve it in O of n. But with Cadence algorithm, we'll easily be able to solve it in O of n. So what does the Cadence algorithm say? The Cadence algorithm is very simple. It says that if there's a subsequence that is contributing a negative number to our array sum, then we ignore it. Let's see what it actually means. So let's say our array is something like this. So we'll start from here. We'll maintain a variable current sum. And let's say max. Right. So we'll start adding all the elements into current sum. So let's say it's 2. Maximum, we'll initialize it to 0. And 2 is more than 0, so it becomes 2. Then 3. So 2 plus 3 is 5. This becomes 5. Max sum also becomes 5. Minus 10. So current sum becomes 5 minus 10, that is minus 5. But because it is negative, we want to ignore this. So we'll restart our current sum from here. So when current sum comes here, it won't be minus 5 plus 5. It will actually restart itself and give it the value 5. Let's give it the value 5. Moving forward, 8. So 5 plus 8 is equal to 13. Current sum becomes 13. Now minus 2. And max sum also changes to 13 now because 13 is greater than 5. Then we hit minus 20. The sum becomes minus 7. So again, it is a negative number. We want current sum to restart itself. Because as you can see, if we had added this part or this part to the future array, to the future sub array that we are considering, it will only contribute a negative number to the sub array. We don't want that. We want to maximize the sum, not minimize it. Alright. So as soon as you come here, the value of current sum changes to 10. 13 is greater than 10, so max stays 13. We come here, current sum becomes 40. Now 40 is greater than 13, so max becomes 40, and this is also our answer. Alright, so this is what the cadence algorithm is all about. If you hit a negative part, sub-array that is contributing a negative to our answer, ignore that and restart from the next element. This is what we are going to do. Let's see how we can code this. Alright, let's take two variables. Let's call it sum so far, and it's nums of I, nums of 0, and answer. And let's initialize that to nums of 0 as well. Okay, so these are the two variables that we've taken. Now we'll start looping the array I equal to 0 or 1, I less than nums dot length and I plus plus. Now if sum so far is less than 0, is negative, what we'll do is we'll make sum so far equal to the next element, nums of 5, and equal to the new element. Otherwise, we'll just add the current element. Sum so far plus equal to num 5. Otherwise, we'll just add the element to sum so far. After we have done this, we'll just take the maximum value into answer. So it's max answer comma sum so far. Let's try to run this. Alright, there's a okay. We haven't chosen the correct language once again. Very sorry. Use Java over there and try to rerun it. Okay. The for closes over here. This will return answer. Return. In this properly, so the code is properly visible to all of you. Let's run this. The visible test cases have passed. Let's try to submit this. So as you can see, the answer got accepted and we are faster than 100% of the users on LeetCode. So that was it for today. I hope all the questions were clear. And so I'll see you next time. Thank you so much for your patience. And if there's any issue, feel free to ping me. Thanks a lot. Bye-bye.